Hello, my name is Lowell Roberts. I'm very pleased to introduce you to a new tool that was developed to measure the anomalies in pipe using the speed and accuracy of laser technology and has the capability of automatically creating a complete permanent documentation of each step in the process. This tool is very simple to use, lightweight, easily implemented by two-person crew without the need for any additional lifting equipment. I would like to share a little history on why I felt the need to develop this tool. I have been employed in the pipeline industry for the past several years, and about 2 years ago, I was on the right-of-way watching my first anomaly dig with an engineer. During our conversation, we started discussing how the pipe anomalies were measured. I found that there were two commonly used methods. One involves using a 4-foot builder's level and a regular measuring tape, and then manually calculating the results of the measurements to determine the percentage the pipe is out of round. The second method consists of transporting a large, heavy steel ring to the job site that must be lifted into the excavation using a crane, uh, track hoe, or other similar lifting device. There are a couple of known issues with this method. First, the steel ring is very difficult to accurately center on the pipe because if the pipe is out of round where the ring is centered, it's almost impossible to get it accurately centered, which would affect the in measurements. Secondly, this is a very time-consuming procedure because it must be repeated numerous times along the pipe in order to completely measure the length and extent of the anomaly. The crews in the field feel that both methods lack in accuracy and do not have a valid documentation system available. Over the next few days, I kept thinking that there has to be a better, safer, quicker way of addressing this issue of measuring anomalies. And more importantly, having a very detailed documentation of every aspect of the result. Over the next several weeks, I interviewed several very experienced pipeliners and engineers to get an idea of what they would like to see in an updated anomaly measuring system. I then spent many hours researching and developing a system that would be lightweight, easy to use, and address the issues that the pipeliners and engineers would like to see. I finally arrived at a conclusion and a good solution and was issued a patent on the pipeline laser solution. This video presents the 1220 model pipeline laser solution, which accommodates pipe sizes from 12 to 20 inches in diameter. There are several other models available that will accommodate pipe sizes from 4 inches to 50 inches. And get you some popcorn, get comfortable, and enjoy the video.
Hey, I'm Jeff and this is Keith. We're going to be demonstrating the pipeline laser solution today. This is a product that was designed specifically for the pipeline industry to measure anomalies on pipe. This tool will measure down to 2 millimeter accuracy. That's about a 32nd of an inch. And it was designed where two people can handle the equipment, a two-man team. With about 3 hours of training, you'll be ready to set this up. As you can see, we already have this set up in place. There are videos that will show you how to set everything up, but today we're just going to be demonstrating what this equipment will do and how easy it is to use. I've been in the pipeline industry and have seen different types of equipment, and this equipment to me is as simple but accurate, more accurate than most. As you can see today, we're using a piece of sonotube, which is more of a cardboard type material. It's much lighter, but it serves the purpose to where we can put an anomaly in the pipe and then we can measure it. But one of the things that we found is in the field, pipe is usually not laid level in the ditches. It's going to be a percentage of maybe anywhere from 1 to 7% slope. So the first thing we like to do is, and all this equipment comes with your unit, is you've got a level here and it's approximately 2.6% out of level. And so once we find that out, we can start setting the equipment up, and we have a measuring device here that points out to a target. And once that gets centered on that target, then we are parallel and we're centered to the center of the pipe. So all our measurements all the way around will be exactly the same from here, from the laser to the center of the pipe. Okay, now that we have that set up, let's go ahead and talk about the arm here. It actually extends, and that's what gets the different lengths out to the anomaly. It's 1-inch increments on center. There's a starting point that we start, and the reason we have a starting point outside the anomaly, we want to try to find a place on the pipe that's less than 1% out of round. That way we kind of have a basis to start with. Okay, now at this time we're going to go over the tablet part of the demonstration. The software is preloaded on the tablet that you'll receive with the system, and let me just go through a little bit of it and get started. First off, you're going to start filling out the pertinent information for the project, the people on the project, the type pipe, the size, the grade, all the things that are important, the coating, the class of the soil, all the pertinent information. As you go through that, this will generate a report at the end that you can turn into the engineers or whoever the decision makers are to say what happens if we're going to have a repair on the pipe, if we're going to have a cutout or whatever. They can determine that, because the tablet can be set up to where it will do a percentage of the diameter of out of roundness. If it's a lot of companies go with 6%, and if you set it 6%, once you get out of that 6%, it's going to let you know, and then at the end it's going to draw that diagram for you for each measurement and show you that. So it's a real good report that you can turn in very professional. Okay, now Keith is going to turn on the laser, and we're going to pair this tablet up to the system. Got it? Okay, now we're going to connect, and that connects us to there. It's a Bluetooth connection. All right, we're on the starting position, right? Okay, we're going to go ahead and take our first measurement. Okay, you can move into the second position, and we have 24 positions around the machine, and we'll take a measurement at each position. And as you can see, you cannot take another measurement till the red light goes off the take measurement. And you can see it's a little bit out from the original. Let's go on to the third position. Okay, take a measurement. As you can hear, that snaps into place, so it's very accurate on how it does. Okay. Next position. Okay, moving right along, and as you can see, when you're on an anomaly dig, you want to not have to have too much room under, so you don't have to dig out a lot of rock and all. And this can be less than 24 inches, and you can use this piece of equipment, which is very good. Okay, you moved it. All right, take a measurement. Okay. As you can see, two people can easily do this work, and okay, and the training, maybe 2 or 3 hours of training, and they'll be up to speed. Okay, next. Okay. Okay, it's coming on inside now. Okay, Keith, are we at the 14th position? Okay, I'm going to take that measurement. Okay. All right. That's 15. Go on to 16. Okay. Okay, we're ready. All right. Getting ready to take number 19 here. And they're at, like I said before, there's 24 positions. All right, go on to next one. And these are roughly taking measurements every 2 inches around the pipe. Okay. Okay. All right. It'll take that measurement and it's going to close. We have the first set of measurements done. So what we're going to do is we're going to go ahead and move out closer to the anomaly and start our next round. So we extended the arm out 30 inches, and now what I'm going to do is I put that in the computer that we went 30 inches, and I'm going to hit yes, that we accept that. And let me put my glasses on. And it shows a red line out there that shows the inches. Okay, that completes the second set of measurements. Okay, now before we go to the next measurement, we want to add some photos, and this software allows you to do that. And for each time you measure, you can add up to 6 photos. So this is really good, and it documents it very good. So what I'm going to do is I'm going to add photos, and I'm going to step around here, and Keith, I'm going to take one without the measuring tape on it, and let me focus in. Okay, Keith, if you'll do the tapes, the length of the anomaly. Let me zoom in on that. As you can see, that anomaly is about 9 inches long. Okay, let's go up and down. And what's your height there? About almost 8 inches. Okay. And then you save those and you have the photos. Okay, now we're going to take our final measurement. We're getting over to the edge, the far edge of the anomaly. So I'm going to go ahead and put that in and push yes. And we're ready to start taking measurements. Are you ready, Keith? Okay, that finishes up this circumference. Now that we're finished taking the measurements, I'm going to hit finish, which that's going to produce a PDF report, which can be printed out. It can be sent directly from the field to the engineers, the decision makers, whoever's going to make the determination on if this was a cutout or a repair. So it makes it easy for you to send the information in, and within just a few seconds, people making decisions can see your information. Start from the beginning, and it has all the pertinent information that the reader can see, who is out there, all the specifications on the pipe, and okay, as you come through the first one, actually the first one you'll see it was not outside. That was your starting measurement. We didn't do any photos on that one. And then your second measurement, you have your measuring number there. You can see the times that we got out of the 6%. They're in red, and there's your diagram. Easy to read, and we did a few photos after that one. And moving on, you'll see the measurement number 3, a lot of it, 6% showing in red. It's very straightforward, but it has a lot of detail to where the readers can make decisions with this information.